Hi, I'm Dr. Randy Martin with the Marcus Heart Valve Center at Piedmont, Atlanta, and I'm thrilled to be joined by Dr. Steve Little. Steve is Associate Professor of Cardiology at the Houston Methodist Heart Valve Center. Steve, thanks for joining us.
Thanks, Randy.
You've made some major contributions in echo, lots of them, but one of the things that really fascinates me is three-dimensional printing, and obviously we hear a lot about it now. But you've really sort of pioneered this with aortic and mitral valves. Tell me a little bit about that.
Well, we started with patient planning, so we're heavily involved in TAVR. One of the questions we had is we see a lot of, like everybody, some paravalvular leak. Wondered if there's a way to sort of predict it a little better. So we've had a flow loop we've developed for years. We then started to take the CTs of patients who were going to get TAVR.
Okay.
We took that CT data set, you put it into a sort of a software station, usually mimics. And then we have a bioengineer who converts that sort of CT data set into just the anatomy we're interested in. So typically left ventricular outflow tract, aortic valve, aortic cusps, ascending aorta, and you make, and then you send that to a 3D printer. The 3D printers these days are amazing because they can actually allow you to choose different materials and to blend them.
Right.
So you can have hard things like calcium.
So you can
have
do calcium,
soft things like deformable aortic roots and cusps. So really through trial and error, you come up with sort of a material recipe that you apply and you create patient-specific aortic root complexes.
So when you do that then, so you've got this thing in your hand, now are you planning on what size and type of TAVR you're going to use?
So the first thing was to say, can we make them? And, then the next question is, do they function like aortic stenosis? Because our long-term goal is to do TAVR on the model.
Right, that's what I'm thinking.
To recreate not only the systolic event, but the diastolic, the outcome, the paravalvular leak or not.
Sure.
So then you've got a sort of a controlled situation where you can create PVL. But then we said to do that, we need to basically take the model and plug it into a flow loop.
Correct.
So that's what we've recently done, is we actually replicate the patient's hemodynamics through the patient's print, and we recreate first aortic stenosis. So we just published, we've done that in about 8 different patients, and it's a very good replication of the function.
Wild. That is
so
wild.
It's a functional, patient-specific, three-dimensional model. We've just presented at AHA earlier last week, sort of a flip side, where we take the same kind of model, but now we're replicating aortic regurgitation. So these are all the steps. First, you try to make the AS, we've done that. You try to make some AR, we've just done that. The next step is to do TAVRs within the models. And now that we have a system where you can actually, find AR and find the echo parameters that look like AR, you replicate the hemodynamics, and that's actually an AHA-funded project we're working on.
That's cool.
Yeah.
And I could keep going on that, but tell me about the mitral. So the obvious thing is, if mitral's a little bit more complex in a lot of ways. So can you print a model and then you figure out what kind of surgery you're going to do or what kind of intervention you're going to do?
So mitral is harder. We've started on that within the last year. We've done mitral printing both from a 3-dimensional volume TE.
Okay.
That's a little tougher because the leaflets come out kind of thick, so you have to adjust that a bit.
Right.
The CT data set is a little more robust and easier to work with. Doesn't have the same temporal resolution as an echo though.
Correct.
So we've printed some mitral valves. We actually have a procedure planned for Monday. And this is an unusual case, and I'm going to show it in a talk soon. But basically, it's a patient who has a perforation of the posterior leaflet.
Okay.
We're planning to do a sort of complicated plugging procedure. But to plan that, to do the procedure, to practice it, we had to have something to practice on. So we've recreated the valve with the calcification, with the hole, with the left ventricular outflow tract. So in terms of procedural planning for transcatheter devices, we couldn't do the case we're planning to do unless we'd had a model to practice on.
That's wild. And again, I could keep going with that. Tell me a little bit, though. You're going to be giving a talk shortly on 3-dimensional modeling of the aortic mitral curtain. Tell us about why that, and why is that important?
Well, that's really sort of the geography between our two projects.
Right.
So the aortic and the mitral, you sort of get it incidentally. If you're printing all that anatomy, it's there. The reason it's important really is looking forward to all the transcatheter mitral valve replacements. So all of these technologies are going to have to grab the annulus, they're going to have to displace the leaflets in terms of the new mitral technologies. But one of the real challenges is replicating that aortic mitral continuity, and as Dr. Graburn says, you're putting a Coke can into the mitral valve.
Correct.
And you've got to figure out before you do the procedure whether it's going to interfere with the left ventricular outflow tract. So in terms of being able to physically hold a model with all the angles replicated, try to put a device in, and see not only does it grasp in the mitral position, but does it interfere with the ejection. And if you've got a physical model, I mean, you can do it probably on a CAT scan, but in terms of your confidence to move forward.
So
you're solid.
Steve, is that going to be based upon not only the angle, but so in essence the position of the anterior leaflet as you manipulate
well,
all that?
It's
Is
going
that
to be
right?
it's going to be all of it. It's going to be the septal bulge.
Correct.
So how thick is the
Right.
septum? What's the length of the anterior leaflet? What's your implant choice? You know, if somebody has a thick septum and you have choice with the device, maybe you'll implant a little
something
higher.
Right.
You know, if somebody has a kind of a planar aortic and mitral angle at the same angle, which is rare, but they're in great shape.
Right.
If it's a little lady with a
It's-
tiny
so
ventricle
it's
and they're like
basically-
this.
It's basically like predicting postoperative SAM after mitral valve
That's exactly
repair.
right.
It's
And
the same thing
this
you're
is
looking
really
at.
predicting intraprocedural problems.
That's cool. That's
Yeah.
cool. Well, so the very, very exciting stuff, and congratulations on doing it. You continue to educate us, so thanks very much. Thanks for joining me.
Thank you, Randy.
Thank you all for joining us. Stay tuned.